section 7.5, using proportional relationships. So, knowing that we have similar objects, using the proportion, the ratio between them to problem solve and find unknown amounts. So that is called indirect measurement. We're not going to directly or primarily measure something. We're going to use other measurements to find out an unknown. So we're going to use the ratio in triangle ABC to figure out what h is in triangle FGH. So using this ratio to indirectly measure h and apply this ratio to this triangle. So we're going to want to set up a proportion between the two. So Tyler wants to find the height of a telephone pole. Why? Who knows? He just wants to. And for some reason, he's going to use shadows. He's very ingenuitive and has a liking for some resources. So Tyler is 5'9". His shadow, when he measures it, is 7 feet 8 inches. So we want to convert those. 5'9", that is 5 and 9 at 12 is 3/4. So 5 3/4. So make that an improper fraction. 5 times 4 plus 3. So 23/4. So do the same thing for the shadow. 7 feet 8 inches. That is 7 and 8 under 12 is 2/3. So 7 and 2/3. And then convert that into an improper fraction. So 3 times 7, 21 and 2. So 23/3. Okay. So we have 23/4 to 23/3. We have h and the shadow. So again, when they set this proportion, I want some commonalities when I set them up. So like I said earlier, big over small, or in this case, I'll do height versus shadow and height versus shadow. So the ratio for the small triangle equaling the ratio for the big triangle. So height over shadow, so 23/4. So make a really big, ugly fraction over 23/3 equaling my other ratio. So I'm doing height over shadow in this triangle. So for this triangle, I want that consistency set of the same ratio. So height over shadow. So h over, I never converted this, so 38 and at 4 inches, 4 to 12 is 1/3. Equaling 3 times 38, so 3 times 30 is 90, 3 times 8 is 24, so 90 and 24, 114 plus 1, 115/3. So h, the height, over the shadow, so 115/3. So now I have my proportion. So I want to solve this and to use cross product property. So this cross is easy enough, 23/3 times h, 23/3h equaling, and then this proportion times itself. So 23 over 4 times 115 over 3. So do denominators first, that's easy enough. Bottom times bottom, 4 times 3 is 12. And 23 times 115, you figure that out, you get about 2645. So then to solve for h, you want to divide by 23 thirds, but remember, we don't divide by fractions, we multiply by the reciprocal. So times by 3 over 23 on that side. And then algebra, you do anything you want, but you got to keep the equation balanced. So you could do anything you want, but you got to do the same thing to both sides. So on the left side, these cancel. Leave us with just h equaling 2645 over 12 times 3 over 23. So multiply those together, get 7935. Over the 12 times 23, get 276. So you want to reduce that down, and that will reduce down to about 28 feet, 9 inches. So indirectly, by not climbing up the telephone pole, because that's dangerous, possibly illegal, Tyler can find the height of it by using a shadow and a little bit of geometry and proportions and ratios. Now a lot of what we've been doing so far with these indirect measurements is working within the one-dimensional space. So looking at length or distances. But we want to branch out from that a little. So maybe not just a length or distance, but maybe an area or a volume. Look at more and more dimensions and how these ratios and how these proportions can compare. They can vary, and depending on the dimension, could they be the same as another dimension or different? So a lot of times you'll see indirect measurements in blueprints or schematics. So obviously you can't draw a whole house to scale on a sheet of paper and carry that paper around with you really easily. So you make a scale. So for example, this one has 7 meters, 10 feet, and then a smaller representation of the airplane. Here I have a scale of 1 to 100. So this length of this patio is 100 times longer in real life when you actually build the house. Now we want to look at a little exploration. So using what we know to find something new. So draw 2 rectangles, easy enough. Sure. And one of the rectangles has side lengths twice as long. So I'll try and do it to scale. It won't be. But once I put the numbers on, I'll be good. So let's say 2 and 3. Let's just fill them all in. So another 2, another 3, and this rectangle has side lengths twice as long as the first. So 4 becomes, or 2 becomes 4, 3 is 6, another 4, another 6. So what are the relations between the ratios, the size the perimeters and the areas. So the size we know that that's a 2-to-1 ratio. We were given that ratio. So let's look at the perimeters. The perimeter of this one, 2 plus 3 plus 2 plus 3, so 2 plus 3 plus 2 plus 3. End up with 4 and 6, so 10. Let's look at the perimeter of this larger rectangle. So we have 4 and 6, and another 4 and another 6. So 10 and 10 give us 20. So 10 to 20 looks like we're doubling it. So times 2, that's what it looks like. Let's look at the areas also. So area of the smaller triangle, or sorry, rectangle, 2 times 3 to get 6. Area of the larger rectangle, so 4 times 6 to get 24. Now from 6 to 24 looks like we're multiplying by 4 or by 2 squared. This times 2 is like 2 to the first. Oh my goodness. A one-dimensional measurement, the perimeter, is 2 to the first, one-dimensional. The area, 6 to 4, times 2 to the second, two-dimensional, 2 to the second. I wonder if that holds up with explanation number 2. And then you want to look also at the next page in notes and look at those results and possibly problem solve the problems at the bottom of that page, and then check your work with my completed notes online.